Video that I'm creating for this week 2 of our virtual lab experience. I'm going to show you now how we can take our simulated signal that we've analyzed doing an RMS and how we can save that to a file on the computer. Okay. So the first thing I'm going to do, just to make sure my LabVIEW is running the way that I want it to, I cleaned up my block diagram a little bit because I wanted to build in room to build a few features. I'm going to go back to this like 25.0 and 0.2 just so I can kind of dial into some nice values. And we'll push play. Yep, and everything is still running the way that I want it to. So let's go ahead and push stop. And now I'm going to show you another one of these really handy sub VIs. So I'm going to right click in my block diagram. And let's see here. So I'm going to tack this down because my floating head is in the way. And let's see, under, oh my gosh, oh, yep, under measurement, under programming, the main one, file IO, I'm gonna click that, and I've got this right measurement file, okay? So I'm gonna click that one, and I'm gonna place it over here. And just like in those other sub VIs I was using, you can see I get all kinds of cool options here. So, and in this new LabVIEW, this is even new for me. I was pretty excited to see that they have this Microsoft Excel format, which is pretty exciting. Previously, I've always done a text file format, which is fine. We can dump a text file into an Excel file. But this is pretty cool. We've got an option to do Microsoft Excel. I'm going to delete this file path, and I'm going to show you how I can create a control so that a user has the ability to make that file path on the front panel. I'm going to say save to one file. Instead of saying rename existing, I'm going to say append to file, and you're going to see how that is a pretty handy trick. And on my time column, I'm going to say one column only, and that's going to each, column that I get, there's going to be a timestamp on that. And, because in this case I have the RMS signal as well as a standard deviation, I don't need each one of those data sets to have a time stamp. I just need a timestamp for the whole thing. So that's where I want one column only. And now I'm going to push OK. And then let's close this functions palette. And now similarly, I can scroll down. And I have tons of options here, okay? So let's start building these up. And so one of the first thing that I want to do here is wire up that file path. And I'll point out here that notice that it wants an input coming in from the right-hand side. That's how I know that's got to be a control. And then notice how there's a file name out with an input on the right-hand side going right to left. Excuse me, this file name is, it wants a wire from left to right. That's how I know it's a control. This file name out, because the arrow is on the right-hand side and wants an arrow going towards the right, that's an indicator. So I want a control so I can tell it where I want the file to go. So I am going to right-click, and I'm going to say create control. And beautiful, it already creates a file name path control, great. And I'm gonna move that down here, okay. And let's see, I don't necessarily need to see that that's the file name. That's pretty obvious to me. So I'm gonna say visible items and turn off the label. And we'll make it a little bit bigger so we can see. Let's go 24. Okay. So right now, it doesn't have a file path. The other thing that I want to do to make sure that it's not recording the data as soon as I push run, because by the way, creating data in a file like this is very computer resource heavy. And we will absolutely crash our computers if we have this recording every single data point. So I want the ability to enable recording. Okay, so let's make a button, right? If we want to turn something off or on, we use the Boolean. And I also want to have a little LED indicator to tell me when it's on. So that's why I like this push button, because not only does it have the button, but it also has the LED indicator. And instead of saying Boolean, I'm going to say record data. All right. And yeah, let's make that bigger. Sure. And we'll even make the button a little bit bigger so we can see it. Oops, let's see here. We'll make it larger. Okay, great. And then now I've got to bring that up over here, and I want to wire that into the enable feature. Okay. So that's going to be under enable. Okay. And then now finally, I have to tell it what data that I want to be in there, right? Okay. And so I'm going to go, I want the RMS signal and I want the standard deviation. And the reason why I want those is because I don't need like thousands of data points, right? If you recall, on this simulated signal here, I've got this taking 1,000 data points per second, and I'm viewing 100 of those at any given point in time. That is going to crash my computer in a hurry if I'm having this generate 1,000 data points per second, right? In 10 seconds, I'd have a 10,000 cell spreadsheet. I don't want that. And I'm also going to try to save some resources on my computer, and I'm going to go 100 and 100. And that's going to give me 1 data point per second. And that 1 data point is going to be an average of 100 data points, okay? Which is why I really want to get the RMS out of that, not the raw signal, okay? So I'm going to wire up from the RMS into the signals, and I also want the standard deviation, so I'm going to wire that up as well. And as soon as I combine that signal, I'm going to get that cool looking flux capacitor thing. Yep, there it is. And so which is just taking 2 signals and merging it into 1. And then now something that I've found to be the most stable, initially when you're setting this up, it's nice to give it a file path here. Okay, so I'm going to do file path, and I'm just going to pick my desktop for now. And I have to give it a file name. And I want you to get in the habit of using this file naming sequence for your data. Okay, so today is January 31st, 2021. So I'm going to call my file name 013121. And the reason why I'm going to start with 01 is because if I was taking data over the next year and I want that data, excuse me, and I want that data to be organized chronologically, right? I have to put 01 and then February 02 and then March 03. And the reason why I have to do that is because if I get all the way to October 10, my data files are no longer going to be in chronological order. So I think this is good, a good habit to get into, is to name your files the name of the day. And I would write that in my lab notebook, right? On my lab notebook, I would say file name 013121, and today is January 31st, 2021. Okay, so I'm going to say okay. And so it's already giving me that file path to begin with, so that's nice. And we'll say okay. And let's see here. If I now run this thing and notice here that I don't have the record here on, I can go ahead and select that. Let's see, I think, oh, yeah, it hasn't created the file just yet, so let's see what happens. So what's also nice about this recording data, you'll notice here, I'm just letting it record because maybe I don't want this temperature just yet, okay? But now when I'm ready for this temperature, I should, in principle, be able to push that button. Let's see here. And then now, oh, it gave me an error. Okay, so I think I know what went wrong. Okay, so let's see here. Aha, so I think I know what happened. With this initial setup, I've noticed this thing, what it wants you to do initially. So did it make my file? Okay, it didn't make my file yet. So when I double click in here, yes, so I probably should have had that set up to begin with. I probably should have started there, okay? So I'm just gonna keep recording this. I'm not gonna edit this mistake out because you'll see how I myself deal with mistakes. Oops, and then I definitely wanna make sure, I'm gonna push that finger button and make sure that that button is off. Because if that button was turned on, as soon as I start running the file, it's gonna start recording. So now that I have this folder in there with today's date, now what I'm gonna do is right click and say file name and say create control. Okay, beautiful. And so now that file path is in there. And like I said, I think that this just helps in this initial setup. Okay, so I don't want to view, I don't need to view the label because I'm pretty confident I know what that thing is there. So let's make it a little bit bigger so we can see what's going on here. Okay, great. And so now, I'm gonna cross my fingers, right? It should work. So let's hit run. Great, so my program is just acquiring data. We're recording, perhaps we're just recording room temperature. And maybe I want to start my day by knowing what room temperature is, and I want to have that recorded electronically. Okay, I jot it down in my notebook. File name is 013121.xlsx. Okay, now, oh my God, cross my fingers, cross your fingers too. Let's hit record data, and I'm just gonna wait for a few seconds. I'm going to let it record a couple data points. I've definitely noticed that just this recording action, you can probably tell it's majorly slowing down my computer. So that's why maybe I recommend you only do like 10 samples per second, 10 hertz, and 10 and 10, 10 samples per second, and average 10 samples at a time to still give you one data point per second. So now I think that's recorded plenty, and I'm not going to push stop. Rather, I'm just going to uncheck record data. And so now you notice here it's going to have to catch up. Yeah, you noticed here it had some lag. Okay. But now what's cool about this is I've recorded that data, but now I'm still letting my VI run and measuring the temperature. And so now if I minimize this, oh, sweet. See, I got that file on my desktop. And I'm going to open it, and let's just see what it looks like. I keep getting these random error messages on this Excel file. I don't know what that is. I'm going to say go away. And now look at this. This is really cool. So I had to double click that A because, if I make it too small, it can't view it. And now look at that. I got all of those digits recorded. And if I look here, I should have been getting a data point every 1 second or so, but I think there's definitely some processor lag going on. And I also have no clue why it thinks that it's 5:25 in the morning, so perhaps there's something going on with the internal clock over VLab. But all the same, it doesn't matter because I've got the date in there, and that's what's important, right? And then I can also see that, this was at 5:25:39. The next data point was 5:25:41. So I have the feeling that it's something to do with my loop needing to go all the way around, giving me a data point every 2 seconds instead of every 1 second. But whatever. I'm fine with getting a data point every 2 seconds because what's important now is if I had a hard time trying to estimate by my eyeballs what those data points, what that temperature actually was, I now have some really high precision on what that data was. So, and I could even, through Excel, right, I could even say, you know, equals average. I could take the average of all of these, right? I could take the average of the standard deviations. And now I have got some really large certainty what room temperature is with some great precision. So maybe in my lab notebook, then I could record this as 22.50 plus or minus 0.11 or something like that, okay? Depending on, of course, how confident I am where the uncertain digit is. And that's actually just gonna come from the physical probe that you use and how well you calibrate it, right? I wouldn't believe anybody if they told me 22.50246. There's no way you know that to that high a degree of precision. But maybe 22.50, yeah, I'd buy that, okay? And so now I'm gonna go ahead and just delete this so that I can keep writing on top of this Excel file. And I'm gonna close it. I'm not gonna save it. So I still got it on the desktop there. And what's pretty cool here is you can see that my LabVIEW program is still running. It's definitely not happy with me, like it didn't show me any of those data points because I'm screen recording, I'm doing this over the internet, so I'm using a lot of computer resources. So in the lab, I expect that these programs will run with lightning speed capabilities, okay? So now let's suppose I'm actually heating something up and my temperature changes. Okay, so I'm heating something and then maybe it finally is leveled off. And I can see visually on my graph, oh yeah, I heated something up and then now that temperature has finally plateaued. I wanna know now what's this new temperature, okay? So with the same file path, I can say record data, and I'm just gonna let it record for a few seconds so I can collect a couple of those data points, right? We'll let it go a couple more seconds here. And then now I'll uncheck record data, and you can see it's gonna catch up with the lag of my computer. Yep, there it goes. And now I'm gonna go ahead and open that file back up. You wanna keep these files closed when you're doing this kind of an operation like what I'm doing. And so now I'll open this file, I get this weird error message, I don't know what that means. And now look at this, beautiful. So you can see here 5:25:53 a.m. and then 5:35. So that was a long 10 minutes in between those two data points, assuming this clock is accurate. And then now you can see, look, it recorded the new temperature value, okay? And if I was doing an experiment where I was constantly like heating something up and letting it get to a steady value, and then heating it up again, and then heating it up again, and then heating it up again, I could keep recording in this fashion. And not only would I be writing this down in my lab notebook, you know, maybe estimating from my block diagram, but then I could get a really, you know, a much more precise value than my eyeball estimate recorded in this computer. Okay, and so now I'll close it. I don't need to worry about saving it because I didn't really do anything important to it. And so now suppose that, so I'll stop this. So suppose we've finished out the day, all right? And we're done experimenting for the day, and we're gonna go home and et cetera. And now we come back the next day, okay? We wanna create a new file. I fully recommend that you do that. So I fully encourage new files for each day where that file has the day's date, okay? So now what I could do in here, and I'm gonna, based on what you just saw, I'm gonna do this preemptively by just going into here now so I can edit this instead of double clicking on the front panel. Or excuse me, instead of editing on the block diagram, I can edit this on the front panel. So now all I'm gonna do is just change the name of the file. And so suppose it's the next day, so February 1st. So I would go 02/01/21. And now in a folder, these are going to be in chronological order, which is great. I'm going to hit the check mark there. All right. And let's just start running the program. So perhaps I'm not ready to record yet. I just want to run the program to make sure things are good. And then maybe I've got a different temperature. You know, maybe I've heated something way up here to 50-ish degrees. Okay. And so now the graph gives me nice visual confirmation that I've heated this thing up and it's no longer changing. Maybe it's at a steady value. All right. So now, cross your fingers. Let's hope it works. Record data, and we're going to let it record for a few seconds. Okay. And yep, my computer is definitely having a hard time keeping up over the internet and with everything I'm doing. So now I'm going to uncheck the record data. We'll see it catch up here. Yep, there it goes. And now as I minimize this, fantastic. I've got another file in there for the next day. All right. And when I open that, I should see the new temperature value. Yep, the 53-ish degrees. Okay. And of course, the timestamp is still showing 013121 because it's not actually February 1st any longer. But all the same, this is a great way that we can use those computational skills to really keep track of our, not only our data itself, so, right, this would be the data, the actual temperature, but this also helps me keep track of the metadata. So in other words, the date and timestamps. Okay, that's super important, especially if you're doing experiments for several months or even several years. You know, perhaps you might be running this experiment, not in this class, obviously, but maybe you're running an experiment for a couple of months. And you want to remember what you did a few months ago. Well, now, not only have you recorded the date, time, and file name in your lab notebook, the computer has recorded that for you as well. So if you're going back and looking at your old data, and you've, of course, taken notes in your lab notebook that says, I was boiling hexane or whatever, and this is the temperature that it boiled at, right? You've got all of that metadata recorded, okay? So this concludes what I want for you to accomplish in this second week, and I want you all to do this individually, okay? And I'm gonna leave you instructions on the group project that I want you to do. So in your group project, you're gonna build on this and you're gonna add a couple of extra things. And I will spell out what those extra things are in another video and document. But please make sure that this saves for you. Like I said, if you have to turn the sampling frequency way down so that you don't crash your computer, that's okay. I mean, you could even have this so that it gives you a data point once every 10 seconds if you need to, right? So use some of that dimensional analysis skill to work out what your sampling frequency should be, you know, if you want a data point maybe only once every 10 seconds, for example. Okay, folks, I'll see you later.